Hello all, welcome to my channel. So in this video I'll be covering the most important topic, that is haloalkanes and haloarenes. So I'll be completely following the NCERT textbook. So whatever the topics that are covered in the NCERT book, I'll be teaching in this video. So in this video, I'll be teaching the basic concepts, that is what is an haloalkanes, what is an haloarenes, and what are the classification of the haloalkanes. I'll be covering in this video. In my next video, I'll be teaching about what are the preparation and how it is prepared and what are the types from which it is prepared and all. I'll teach in my next video. Okay, so coming to it, what is haloalkanes? The question comes here is, what is this halo and what is this alkanes part? So it is nothing but it is the basically the replacement. It is the replacement of, it's a replacement of hydrogen atom. It's a replacement of an hydrogen atom by an halogen atom. By an halogen atom. Okay. It's basically replacement of one hydrogen atom by an halogen atoms in an aliphatic hydrocarbon. In an aliphatic hydrocarbon. So this is a definition of an haloalkanes, replacement of an hydrogen atom by an halogen atoms in an aliphatic hydrocarbon. I'll tell you what and all, what does this sentence mean, explanation I'll give it. So what is haloarenes means, it's also the same definition, replacement. It's basically a replacement of hydrogen atom by an halogen atom in aromatic hydrocarbon. The only difference is that hydrocarbon. The only difference is that you are replacing an hydrogen atom by an halogen atom in the aliphatic, whereas in the haloarenes concept, you are replacing in the aromatic hydrocarbons. So we all know that in the hydrocarbons, it's classified into two parts, that is saturated and the unsaturated. So in the saturated, it's basically a carbon-carbon single bond. Okay, like it's an alkene part. And in the unsaturated, it's basically a carbon-carbon double bond, carbon-carbon triple bond, that is alkene and the alkyne. It's kene, it's kyne, it's ane. Okay, so we'll be in the haloalkanes, we are talking about this alkane bond, that is carbon-carbon single bond. Okay, see, for example, I'll give an example and tell you so that you can understand. It's basically how it works means, for example, an alkane is taken, you are removing an hydrogen atom, you are removing, instead of that you are replacing with one halogen atom. Here X is nothing but an halogen atoms and you are getting nothing but an alkyl halide. See, for example, I'll take methane. What is the formula of methane? CH4. So you know that alkane, what is the, how to write it easily, like CnH2n plus 2, right? So meth means only one carbon, one N, like one carbon. So it's CH4. If you put N value as 1 means you will get it as CH4. Okay, CH4, when you are removing one hydrogen from the methane and you are adding one more halogen atom to it, you will get, if you are removing one hydrogen from CH4, what is there? CH3, and one halogen you are adding to it. This part you are adding to it, what you will get? X. So here halogen, what are the halogens I am mentioning? I mean is that in this video, it's fluorine, it's chlorine, it's bromine, it's iodine. So these are the halogens. Okay, one more example I'll take ethane. So the same thing you put in this formula, like eth means it's 2. Okay, C2 H6. Okay, just you need to know this formula. If you know this eth, prop, but, all you can do. Okay, C2H6. Here you are removing one hydrogen, you are adding one halogen atom. If I add, for example, chlorine, what you get? C2H5Cl. Okay, ethyl chloride. This is nothing but an ethyl chloride. Okay, I hope you are clear with this haloalkanes. What does this sentence mean? Replacement of hydrogen atoms by an halogen atoms in an aliphatic. Okay, I hope it's clear. Now I'll just give an introduction for this haloarenes as well. How does it work and all. So haloarenes, you know that it's a replacement of the hydrogen atoms by an halogen atoms in an aromatic hydrocarbon. Okay, like for example, if I'm taking a ring of a benzene, listen, if I'm taking like this, the same thing, you're just replacing an hydrogen atom with one halogen atom, you're getting like this. Nothing, you have to just remove one hydrogen and replace with the X. This is only the haloarenes. Only the aromatic compounds are involved in it. That's it. The only difference between haloalkanes and the haloarenes. Okay, I think the introduction part and what is the definition behind it, it's clear. Now let's move on to the classification of the haloalkanes. Okay, so first we shall see the classification of the haloalkanes and then we'll go for the classification of the haloarenes. Okay, classification, I'll write it down here. One second. Classification of haloalkanes and haloarenes. Okay, so here they are classified basis on different cases. So we shall see each one of them. So first thing is that they have classified on the basis of number of halogen atoms. So first thing is that on the basis of number of halogen atoms. Halogen atoms. Okay, so first classification is that they have classified basis of the number of halogen atoms. First one is monoalkane. Monoalkane. Okay, the second one is dihaloalkane. Okay, what does this monoalkane means? We all know that mono is nothing but a single. It's like a one. The practical thing, whenever you read the word mono, di and all, what does it come? Mono is 1, di is 2, tri is 3. That's a basic thing whenever you see a words like this. Monoalkane. So when only one halogen is present in a compound, we call it as an monohaloalkane. Means when only one halogen is present, when only one halogen atom is present, we call it as an monohaloalkane. Okay, so examples, I can give you a few examples. CH3Cl means only one halogen atom is attached to this aliphatic compound. Okay, next one is CH3CH2Br. See, only one halogen atoms. We need to concentrate only on the halogen atoms, not on the other carbon or the hydrogen atoms, because the definition states that only when only one halogen atom is present. Okay, in the NCERT textbook they have given a definition like they may be classified as mono, di or tri based on whether they contain 1, 2 or more halogen atoms in their structures. More means you're classified as a polyhalogens. Okay, So we shall see what is dihaloalkanes. Dihaloalkane is nothing but just an opposite of the monohaloalkanes. In mono means we are using only one halogen atoms. In the di means we are using the two halogen atoms. Two halogen atoms. It's very simple. See, when one halogen is attached to one other carbon and the other halogen is attached to another carbon, means when this expert is nothing but an halogen, like you can replace with a Cl, Br, anything. Okay, so when two halogen atoms are attached to one aliphatic compound, we call it as an dihaloalkane. I hope this both part is clear to you all. Now dihaloalkane, again it's classified as, we shall see in the next slide. Dihaloalkanes, classification of dihaloalkane. Okay, so first one is so classification of the dihaloalkanes. So first one is that geminal dihalides, halides, and the second one is vicinal dihalides. Okay, it's easy only. Okay, halides. Oh, sorry, certain spellings are wrong, do adjust it. Vicinal dihalides, geminal dihalides and the vicinal dihalides. Okay, so what do you mean by the geminal dihalides? Means when both halogen atoms are present on the same carbon, we call it as in geminal dihalides. Means, see, so basically what is the definition of dihaloalkanes? Means when two hydrogen are present on a compound, we call it as in dihaloalkanes. Here again it's classified as geminal dihalide and the vicinal dihalide. Here in the geminal dihalide means when both the halogen atoms are present on a single carbon atom, we call it as an geminal. For example, see, for example, one hydrogen, for example this chlorine is present. So see, carbon valence is 4. I think the structure is right. Means these two hydrogen atoms are present on the single carbon atom. The definition is that when two halogen atoms are present on single carbon, we call it as a geminal dihalide. And what is the vicinal, like what do you mean by the vicinal dihalides? Means this you can write it as this you can write it as R. Means R is nothing but as an alkyl part. Okay, like CH3 CHCl2. Okay, the next one is vicinal dihalides. So what do you mean by a vicinal dihalides? Means when halogen atoms are present on the adjacent carbon atoms. I hope it's clear. When halogen atoms are present on the adjacent carbon atoms, we call it as a vicinal dihalides. When halogen atoms are present on the adjacent is nothing but like side by side adjacent carbon atom. Okay, for example, see CH2, here one halogen atoms and here one halogen atoms. Basically the structure looks like this. Okay, Cl, CH, H, Cl. When the halogen atoms are present adjacent to it, and we call it as a vicinal dihalides. I hope it's like clear to you all. Um, Someone asked a doubt like you can write it. Yeah, you can write it just for a sake. I have written like alkyl. You can write it the same way, like CH2 Cl2. Also, it's right. Like you can write like this CH2 Cl. This just for the sake, like whether you can attach the other alkyl halides. Just I've shown, you can write it the same way as well. So we shall see the next classification. Classification based on hybridization. Okay, what is the classification? How it's classified based on the hybridization? Hybridization is nothing but, we all know, we have learned in the chemical bonding chapter in the first in the first PU itself, like hybridization is like sp, sp2, sp3, all this we call it as an hybridization. So how it's classified on the basis of the hybridization, we shall see right now. Okay, so first one is allylic halides. Okay, first one is allylic halides. Okay, so what does this allylic halides means? These are the compounds in which halogen atom is bonded to sp3 hybridized carbon atom adjacent to carbon-carbon double bond to one allylic carbon. Means, I will explain. See, when they meant to say is that when halogen atom is attached, when halogen atom is attached to sp3 hybridized carbon which is adjacent to carbon-carbon double bond, means which is adjacent to the sp2 hybridized carbon to one allylic carbon. For example, see, CH2 double bond CH2X. X is nothing but an halogen atom, so you can replace by using Cl as well. So this is sp3 hybridized carbon. Now because it's single bond, right, sp2 sp3. Now what is the definition? Means when halogen atom is attached to sp3 hybridized carbon. See, this is an halogen atom which is attached to sp3 hybridized carbon adjacent to the carbon-carbon double bond. See, there is a double bond between these two carbons. This is sp2 hybridized carbon, which is the halogen atoms which is attached to sp3 hybridized carbon which is adjacent to that of the sp2 carbon. Okay, the definition is meant in such a way. I hope it's clear. The next one is benzylic halides. Benzylic halides. Okay, so what is the benzylic halides? Means the same thing, the only difference is that you are taking the aromatic compounds here. Okay, aromatic ring you are considering, means these are the compounds in which halogen atom is bonded to an sp3 hybridized carbon atom attached to one aromatic ring. Okay, so benzylic halides means when the halogen atom is bonded to sp3 hybridized carbon, sp3 hybridized carbon attached to an aromatic ring, Okay, the only difference is that aromatic ring is, for example, you're taking a benzene ring and see CH2 X is nothing but anything you can take. So this is an halogen atom which is attached to sp3 hybridized carbon to its aromatic ring. Okay, I hope it's clear. So the next classification we shall see, that is vinylic halides and the aryl halides. Okay, I'll write down here vinylic halides and the aryl halides. Okay. So vinylic halides, what does the definition means? So these are the compounds in which halogen atom is bonded to sp2 hybridized carbon of a carbon-carbon double bond. Just in the previous one, in the allylic, how we have read means the halogen atom is attached to sp3 by carbon adjacent to carbon-carbon double bond. But here vinyl means halogen atom is bonded to sp2 hybridized carbon. That is, sp2 hybridized carbon means carbon-carbon double bond. Okay, say for example CH2 CHX. So this is what, this part is what it is, sp2 hybridized. Okay, many examples you can give as well. Okay, CH2 Br, bromide, chloride, anything you can replace this X with an halogen atoms. Okay, so this is nothing but an vinylic halides. Halogen atom is attached to sp2 hybridized carbon, that is carbon-carbon double bond. So what is aryl halides? These are the compounds in which halogen atom is directly bonded to sp2 hybridized carbon in an aromatic. Means when an halogen atom is directly attached to sp2 hybridized carbon atom in an aromatic ring, if I'm not wrong. Okay, so it's basically an aromatic ring is such a way, it's like this. So this is this part is called as an halogen. Okay, so this carbon is basically, and you know how the structure of benzene looks, it's basically looks like this, right? Sorry, this is not a 1 second. 1 second, I'll draw it properly. So it's like this, right? Right. So there is the hydrogen atoms as well as they are attached to it. Okay. So this is an halogen atom. So here this part is sp2 hybridized. Okay. That's what they're telling. When an halogen atom is directly attached, it is directly attached to an sp2 hybridized in an aromatic ring. It's called as an aryl halides. I hope it's clear. Then classification, next part is we have completed the classification based on the number of halogen atoms, right? Number of halogen atoms. Next we have completed based on the dihaloalkanes as well. And next we have classification based on the number of hybridization, that is sp2 and sp3, whether it's directly attached or whether it is adjacent to it as well. And next we will discuss about classification based on degree of carbon atom. Sorry, classification based on degree of carbon atom. Okay, means degree means you already know that, like it's primary, secondary, or it's tertiary, or like that means like 1 degree, 2 degree, 3 degree. So in such a way that they are classified as whether it's a primary or secondary or tertiary. So we shall see how they have classified according to the NCERT. I am just following it. So first one is primary alkyl halide. It's nothing but the 1 degree haloalkane. Okay, so means when halogen atom is attached to primary carbon. Okay, so means when what the definition will write means when halogen atom is attached to primary carbon is attached to primary carbon, we call it as an primary alkyl halide. For example, see like CH3CH2X means this is a primary carbon. This part of carbon is a primary carbon. When an halogen atom is attached to primary carbon, we call it as a primary alkyl halide. The second part is nothing but secondary alkyl halide. Secondary alkyl halide is nothing but it's an like 2 degree means when an halogen atom is the same thing. When an halogen atom is attached to the secondary carbon, we call it as a secondary alkyl halide. For example, see, you can write it as CH3 and X. This is called as a secondary carbon atom, and when it is attached, the same thing as well as the tertiary alkyl halide as well. Okay, tertiary alkyl halides. Tertiary alkyl halides as well means when an halogen atom is attached to the 3 degree carbon atom, we call it as an tertiary alkyl halides. So let me once just revise it once. So we have learned about what is haloalkanes and what is haloarenes, how it is just replaced by one hydrogen atoms and all. And we have read about the haloarenes definition. That is the only difference between haloalkanes and haloarenes is that in haloalkanes we are replacing the hydrogen atoms by halogen atoms in the aliphatic compounds, whereas you are replacing the halogen atoms by the you are replacing the hydrogen atoms by the halogen atoms in the aromatic compounds. You are doing it, and you have learned about the classification of the haloalkanes and the haloarenes, and you already know that they are classified as monoalkanes, dihaloalkanes, tertiary, trialloalkanes, dialloalkanes, etc. Depends upon the number of the halogen atoms it is attached. Again, you are classifying the dihaloalkane as geminal dihalides and the vicinal dihalides, means you are depends upon the hydrogen where the halogen atom is present on the carbon, whether it's present on the adjacent side or present on the single. Next, it's based on the hybridization, that is allylic halides and the benzylic halides, vinylic halides, aryl halides. Then it is based on the degree of the carbon atoms. Like I can tell you, like when the CH2X, this part is a primary part, and secondary means just you are doing the same thing. CH, just only you are replacing it with an 2 degree, and tertiary alkyl halide means you are just putting the 3 alkyl part and then 1 hydrogen, that is, this is a tertiary. So this part you need to keep in mind, this is 1 degree, and this structure, the 3 structures you remember, R is nothing but an alkyl part, whatever the alkyl, like methyl, butyl, ethyl, etc. So thank you for watching my video. In my next part of video, I'll be continuing this chapter, that is what is the nomenclature and how it is prepared and all. In my next video, I'll be teaching.